In this video, I'm going to show you 5 ways to solve a quadratic equation with integer coefficients. Okay, so here I have a standard form of a quadratic equation, ax squared plus bx plus c is equal to 0. The a, the b, and the c, we're assuming right now they're real numbers, even though they could be imaginary or complex. A cannot be 0 because if a is 0, then this term cancels and all you have is a linear equation, first degree. Okay. Let's delete this. And then right below it, you have what is called the quadratic formula. So that's actually one way to solve a quadratic equation. So let's look at the 5 ways. And basically, the first one we're going to look at is factor. That's the easiest way you could have if the equation factors. And I want to point out that the equation I'm looking at, this applies here when a is equal to 1. Okay. So in other words, I'm looking at the equation here where a is 1. Of course, factoring method will work on other coefficients, but right now it's just a equal to 1. So we're using the zero factor theorem that states that if you multiply numbers out, 2 numbers or more numbers, let's say for example a times b is equal to 0, and the assumption here is that either a can be 0 b could be 0, or they could both be 0. Okay, so obviously that's going to apply if you have several factors. So you could have x times y times z. If this product is equal to 0, then it has to be true that x is 0, or y is 0, or z is 0, or all of them are 0. Okay, and that's what we use to solve equations by factoring. So in the first one here, factor method, say x squared plus 2x minus 15 factors into x plus 5 and x minus 3. So this product is 0. Okay. So we were using the factor method, and the 15 was over here on the right side, and we bring it over because in the factor method we really want one side to be 0, so we can set up this kind of setup. Okay, because in order for this to work, the right side has to be 0, or one side has to be 0. So if x plus 5 times x minus 3 is equal to 0, that means that either x plus 5 is 0, or x minus 3 is 0, or both factors are 0. So if we just solve these two equations, this one add negative 15 to, or negative 5 to both sides, we get x is equal to negative 5. And the second one, we add 3 to both sides, I get x equal to 3. So the two solutions that we can have are x equal to 3, x equal to negative 5, or negative 5 and 3. Okay. So that's the way we could solve this particular equation using the factor method. So clear this. Okay, the method of completing the square. We want to set this up in the method of completing the square. We want to set it up so it looks something like this. Quantity of something squared is equal to some number. Then it's easy to solve. Just like if you have x squared is equal to 25. Okay. Okay, what number squared is 25? Well, 5 or negative 5. 5 or negative 5. Okay. So it's easy to set up. In the same way, if we have x minus 3, quantity squared is equal to, say, 7. Then that means that quantity squared equals to 7 means that this quantity right here has to be either radical 7, because radical 7 squared is 7, or minus radical 7, because minus radical 7 squared is also equal to 7. So we can set this up by saying that means then that taking the square root, x minus 3 can equal to the square root of 7, or x minus 3 can equal to minus the square root of 7. So then we have, solving this one, adding 3 to both sides, x can be 3 plus radical 3. And the next one, again adding 3 to both sides, we get x is equal to 3, and this should be 7 here. 7. This one should be 3 minus radical 7. Okay, so that's the objective on the one that I'm doing. Okay, so it works out nicely if the coefficient of the x-coordinate is 1, because all you have to do in this case is this. Rewrite it so that the constant term is on the right. So adding 15 to both sides, we get this. Okay, so what I'm trying to do now is I'm trying to make this expression on the left side a perfect square trinomial, which means it'll be the square of a binomial. And the way this works is we take half the coefficient of the x term, that's the 2, half of that is 1, and then you square it. And you add that to both sides. So I add 1 to this side, and I add 1 to this side. Okay, so I got x squared plus 2x plus 1. But that factors into x plus 1 and x plus 1. So I'm going to write that as x plus 1 squared is equal to 15, and 1 is 16. Okay, so now just like the one I did a while ago, the square of what number is equal to 16? Well, 4 squared is 16, negative 4 squared is 16. So that's like taking the square root of both sides, plus or minus. So x plus 1 then has to equal to 4, or x plus 1 has to equal to negative 4. Okay, and then we solve this equation for x. So adding a negative 1 to both sides here, I get x is equal to 3. Okay, 4 and negative 1 is 3. So I add negative 1 here and negative 1 here, I get 3, and then doing the same thing over here, I get negative 1, negative 1 and negative 4 is negative 5. So 3 and negative 5 is the solution. Same thing I got by factoring. Okay, so that's the second method. Clear this? Quadratic formula. Okay, this is a quadratic formula. So we simply use the coefficients here, a, b, and c. So it's minus b plus or minus the square root of this expression here over 2a. Okay, so the quadratic formula then will be x is equal to let me write the equation over here so you can see it. It's x squared plus 2x minus 15 equal to 0. Okay, so it says minus b. Okay, so this is a is 1, b is 2, and c is negative 15. So minus b, then this would be minus 2 plus or minus the square root, and then it's inside the right, it was b squared, that's 2 squared, which is 4, minus 4 was part of the formula, and then it's times a, which is 1, and times c, which is negative 15. Okay, and that's over 2 times a in the bottom here, and a is 1. So then we just compute this out. Minus 2 plus or minus the square root of, okay, so this is going to be minus 4 times 1 times minus 15. That's plus, this will be a plus 60 because the negatives cancel out, so it'll be 60 and 4, that's 64. Over 2. Now this 64 wasn't a perfect square, or you couldn't simplify it anymore, this would be your answer. But we can take the square root of 64. That's 8 over 2. Okay, so then we do this. Minus 2 minus 8, that's minus 10, divided by 2 is negative 5. And then minus 2 plus 8 is 6, divided by 2 is 3. Okay, so again, we get 3 and negative 5. Okay, now those are the 3 main methods that you have. Okay, factor method, completing the square, and the quadratic formula. Now the first method you want to use is the factor method, but it's not always going to be the case that the equations get a factor. It might have irrational roots, complex roots in some cases, and it can be difficult to factor. Completing the square will always work. If it doesn't factor for you, quadratic formula will always work. Okay, so remember in the case here, I'm looking at equations with integer coefficients. Okay. So let's clear this. And the next thing you can do is the graphing calculator. Okay, so I just want to point out to you before I do this, if you have some function y equal to f of x, okay, and you graph this on a calculator or just manually, the points where it crosses the x-axis would generate the what I call the zeros of that polynomial. So basically the zeros of that polynomial, or whatever it turns out to be, are going to be the solutions or the roots of this equation, f of x equal to 0. Okay, so what I'm telling you then is you want to solve this in the calculator. Okay, we look at this part right here. That would be your function, f of x. So we enter it in the calculator over here. Y, and there it is, x squared plus 2x minus 15. I already entered it. And then if I hit the graph, there it is. Okay, so the graph intersects the x-axis at this point right there, and this one right here. So look, that's 1, 2, 3, 4, 5 in the negative direction, so that tells me x is negative 5. And over here on the right side, 1, 2, 3. Okay, so I get the same solution. Or you could just look at the table, hit the second key, and then graph, accessing the table there. and you can see when x is 3, y is 0. Okay, so that's a 0, which is a solution. So 3 would be a solution. If we scroll up, let's find another 0. There's another one right there. So -5 is a solution. Okay, so that's one way to do it. Now, if you don't have integer solutions, you can still get the answer in the calculator. Okay, that'll be for another video. But you can still get the answer on the calculator, because sometimes the answer could be something like 1/7 or 1/8. The calculator is just going to give you integer values here. Okay, but there is a way to do it in the calculator if they're not integers. Okay, and then another way is basically the trial and error method. Okay, and this one is based on one of the theorems from algebra, the rational zeros theorem, which tells you if you have a polynomial, which we have here. So we're looking at this part right here. Okay, the rational zeros of a polynomial, which in this case would be the solutions because the right side is 0. If this coefficient here is 1, okay, so remember this, what I'm telling you right now applies when this is 1. And there's other ways to do it if it's not a 1, if it's a 2 or a 3, but in this case it's pretty easy if this is a 1, because the solutions, the integer solutions, if it has any, are going to be factors of -15. So that means the only possible solutions you could get would be plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. So in other words, again, if the equation is in this form where the a is 1, you take the factors of the third term here, the c, and those are going to be the possible solutions. So then all you would have to do is just, like I said, trial and error, plug them in there. Put a 1 there where the x is, and then a -1, see if it gives you 0, and of course we know it's not. Then plug in a -3, okay? See if it gives you 0, we know it won't. But then you plug in a 3, 3 squared is 9, and then 3 times 6 is, or 3 times 2 is 6, 9 and 6 is 15, minus 15 is 0, so we know that then x is equal to 3 will work. And then we plug in a 5 there. 5 squared is 25, and then 5 times 2 is 10, that's not going to work. But if we plug in a -5 squared is 25. Minus 5 times 10 is minus 10. It is minus 5 times 2 is minus 10. And then a minus 15. So minus 10 minus 15 is minus 25. And 25 gives me 0, so I know that -5 works. Okay, so that's a trial and error. Okay, but obviously this one, if you had a choice, you would just factor it. Okay, very easy to get it if it factors and if it has integer solutions. Okay, that concludes the video. Thanks for watching. We'll see you next time.